Welcome to Study Loop.
The radioactive nuclide platinum-199 has a half-life of 30.8 minutes. A sample is prepared that has an initial activity of 7.56 times 10 to the 11 becquerels. So the first thing we're asked is that how many platinum-199 nuclei are initially present in the sample. So we're given initially dN dt at time t equals 0 is 7.56 times 10 to the 11 becquerel, which we can convert into number of decays per second. So this is equivalently dN dt is 7.56 times 10 to the 11 decays per second. Now, you can compute the decay constant as the natural log of 2 over the half-life, which is also given. And this turns out to be 3.75 times 10 to the minus 4 inverse seconds. So now we can use the fact that the number of initial nuclei in our sample is equal to 1 over the decay constant times the absolute value of dN dt at time t equals 0. And plugging in our numbers, we get 2.02 times 10 to the 15. And this is the number of platinum nuclei that are initially present. So the next thing we're asked is how many are present after 30.8 minutes, which is equivalently one half-life. So the definition of the half-life is the amount of time it takes for 1/2 of the sample to decay. So after 38 minutes, only half remain, which is n naught, the initial value, over 2. And so this is 1.01 times 10 to the 15. The activity level, likewise, is proportional to the number of nuclei that are present at that moment. So dN dt, in this case, is 3.78 times 10 to the 11 decays per second. Now lastly, we want to find the same thing as part B, how many nuclei are present in the activity level, but after 3 half-lives. So if 3 half-lives has passed, that means there's 1/2 to the 3rd power, or equivalently 1/8 of the total number of nuclei and activity present. So taking our initial values of n naught and dividing by 8, and the initial values of activity and dividing by 8, we find that the number of total nuclei is simply n naught over 8, and the activity level is dN dt naught divided by 8. And those are our answers.